Okay, so let's start ourselves off with trig. So this is technically math 137 now instead of 136, trig. So lesson 6.1 is where we're going to start. So this starts out with some pretty hefty terminology. So in your book, if you'll look at it in chapter 6, you'll notice there is a whole lot of bolded words that we need to kind of know about. So one is just knowing that you have an angle. In this case, it's angle AOB. Knowing what the initial side is and what the terminal side is. So this is the initial side. This is the terminal side. Same thing with this one, initial side, terminal side. But we're going to talk about coterminal angles, which basically means it's the exact same angle, but they may call it something different. So we're going to talk about that in a minute. The other things that you need to know about, let's see, straight angles look like this. They are calling this 540 degrees, and I will talk to you about what is weird about that in a second. Typically, we would say this is 180 degrees, but 540 and 180 are coterminal. They are the exact same thing. You've got positive angles and negative angles. So positive angles are measured from that initial side going upward and around. Negative angles are labeled from that initial side downward around that direction. So you have positives and negatives. You also have quadrantal angles. Those are where like your 90-degree angles and your 180 and your 270 and 360, where both of your sides are on an actual axis. Okay, so let's start off with some basic information about that. So let's start with this. This says if theta is 60 degrees, and by theta, they mean the degree of an angle. So you'll notice also that a lot of the time they will call these interior angles by Greek letters. So they use the Greek alphabet. If you're ever confused about what to call those, in the back of your book, there's a whole list of them. So they, in this lesson, use theta a lot, and you will see it written usually with the capital, but sometimes with this lowercase as well. Okay, so we're talking about in example 1, you've got this angle theta that is 60 degrees. And it's in standard position, so it's in this normal, you've got this initial side and this terminal side. They want me to find 2 positive angles and 2 negative angles that are coterminal with theta. So I just talked about the idea of coterminal, meaning it's the same angle. So the difference is if you go all the way around a circle, that's 360 degrees, right? So let's say I started right here with this angle. If I went 360 degrees around the circle, I would end up in the exact same spot. If I did that again, I would still end up in the exact same spot. If I went the opposite direction around 360 degrees, I would end up in the exact same spot. So that's what they're asking me to do, is just come up with those values, which is really easy. So the first one, if I just take my 60 degrees and I add 360 degrees to it, so if I went around the circle one time, I would end up with 420 degrees. So that would be one positive coterminal angle. Another one would be, what if I went around 360 degrees twice? That would be adding 720 to it this time. So that angle, being 780 degrees, is also coterminal. Okay, so that gives me 2 positive ones. If I needed 2 negative ones, I could do the same thing, just subtracting instead, because I'm going to go the opposite way around this circle. So I'm going to go the negative direction, which means I'm going to subtract 360. So if I take 60 minus 360 degrees, that gives me negative 300 degrees. That is a coterminal angle, 260. And then 60 degrees minus, let's go twice, so 720 degrees. That's going to give me negative 660. That would be another negative possibility. Now, these answers can vary, and you'll see that in the back of your book. They'll always say answers may vary. That's because they could have said, you know what, I don't want to do 720. I want to do a different multiple of 360. So I could say anything times 360. So let's say times 3, any whole number times it. So maybe I wanted to add 1080 to this instead of 720. That is fine. I would still get an answer that is a coterminal angle. Same thing with subtracting. Okay, so the second part, so they want me to find, so in this example they say find an angle that is complementary to this, but they give me these weird looking angles. So let's have a conversation about what this means. So first let's start out with, we've got degrees. We've talked about degrees before. Degrees are pretty simple. Let me just get an extra sheet of paper here because I don't have a lot of explanation. So when I'm talking about degrees, that's just 1 degree out of the 360 on a circle. But if I'm talking about something smaller, so let's say I'm talking about 0.1 degree, that is the same thing as saying 1 minute. That's what that terminology is. This 1 apostrophe up here is called a minute. So I'm going to write that out here, 1 minute. Then if I had something like 0.01 degree, that is 1 second, or 2 apostrophes up here. So again, I'll write that out just for note-wise so that you have it. Okay. One thing that's really important to remember though, when you're talking about these minutes and these seconds, we really are talking almost like time, right? So minutes, there are 60 minutes in a degree, and there are 60 seconds in a minute, right? So 1 degree is the same thing as 60 minutes. And 1 minute is the same thing as 60 seconds. So if we kind of look at this together, 1 degree is the same thing as 3,600 seconds. So it's like saying there's that many seconds in an hour, right? So it's going in that same idea. So I've got 60 minutes in a degree, 60 seconds in a minute, and 3,600 seconds in a degree. Okay, so that's important in this next problem. So in this problem, they want me to find an angle that is complementary to that. So if you remember back to your geometry days, complementary means they add up to 90 degrees. And if you're ever not really sure about that, in your book, it gives you this table that talks about acute and obtuse, and then complementary and supplementary are right there. So if you forget, those are there. Another way to remember it though, complementary comes before supplementary in the alphabet. C comes first before S, right? And 90 degrees would come before 180 degrees. So maybe that will help you remember it if you get those mixed up. Hopefully you don't. Okay, so this one's pretty easy though, again, because if it's complementary, I know that means they add up to 90 degrees. So I'm gonna take 90 degrees and I'm going to subtract away this 25 degrees, 43 minutes, and 37 seconds. The only tricky part of that is I don't have minutes and seconds to take away from. So I need to borrow. So this is like me saying I've got 0 minutes and 0 seconds. So I need to borrow from those. So I'm going to go all the way back over here to this 90 and make it an 89. So 89 degrees. That would give me 60 minutes right here, but I would still have 0 here. So instead of thinking of this as 60, so this 89, this 60, I'm now going to borrow from that and make it 59 minutes and 60 seconds. So 89 degrees, 59 minutes, and 60 seconds. So 60 seconds is the same thing as 1 minute. And then that would make this 60. So 60 minutes is the same thing as 1 degree, which gives me that 90 degrees back. So I'm just kind of borrowing here, and then that makes it to where I can actually subtract these things. And then you literally just subtract those. So if you need a calculator to do that, that is totally fine. There's no shame in using a calculator. So 60 minus 37 gives me 23 seconds. And 59 minus 43 gives me 16 minutes. And 89 minus 25 gives me 64 degrees. So the complementary angle to that would be 64 degrees, 16 minutes, and 23 seconds. What I love about this second one is they just made it a decimal. If they just have it as a decimal and they want the complementary angle to that, you can literally just take 90 minus 73.26 and just get your answer. So 90 minus, not 90 minus 73.26, that gives me 16.74, and I am done. So it depends on how they give you the problem. If they give it to you with minutes and seconds, you have to answer it with minutes and seconds. If they give it to you as a decimal, you can just answer it with a decimal. All right, example 3. So now we need to talk a little bit more about what radians and what degrees mean. So these are all in degrees. What we've talked about so far has all been degrees. Now I'm going to talk about radians. So radians, when you're looking at a circle, okay, so right here, it talks about 1 radian is the measure of the central angle of a circle subtended by an arc equal in length to the radius of the circle. So they are talking about this situation right here. Right there is 1 radian. And then this is 2 radians. This is 3 radians, and so on. So when you're talking about those, we have to figure out a way to convert those things back and forth. So here's an easy way to think about it. So the circumference of a circle is 2 pi radians, right? 2 times pi times radius, or 2 pi radians. So if I'm looking for 2 pi radians on an actual circle, if that's the circumference of the circle, that's 360 degrees, right? Radians. So I'm going to write it like that instead. So circumference, it kind of like follows from that. Circumference is 2 times pi times radius, or 2 pi radians, and then the 2 pi radians is the same thing as 360 degrees. Okay, so what they give us is a couple of shortcuts here. If we know that 2 pi radians equals 360 degrees, if I divide here by 2 pi, if I divide by 2, I get 180, and divide by pi, I get that a radian is 180 degrees divided by pi. So if I divide by 2 pi right there, that gives me this. So that's where in your book they're giving you this information right here. If I'm going from radians to degrees, I can simply multiply by 180 over pi. So the explanation that I just gave was kind of complicated, but I mean, not too complicated, but that was kind of the reason behind this. This is like your shortcut. To go from degrees to radians, you take pi, you multiply times pi over 180. If you want to go from radians to degrees, you go times 180 over pi. So I just need to know my starting point, right? So in example 3, they started me out with this. If theta equals 3, they want me to approximate this in terms of degrees, minutes, and seconds. So they're telling me that I'm starting with this, which does not have a degree symbol on it. If they give you information like that with no symbol on it, they mean it's in radians. So they just gave me 3 radians. And then they want my answer in degrees, minutes, and seconds, which means I need to do this. If I'm at radians and I'm going to degrees, I need to multiply by 180 over pi. So I'm going to take 3 and I'm going to multiply it by 180 over pi. And this is in degrees. That's how I'm getting my degrees. Sorry about the shadow there. Okay. So this is going to give me about, and you can use your calculator to do this. So 3 times 180 3 times 180 is what I did first. And then I'm going to divide by pi, which I'm going to use the pi button to do that so that I get an exact answer. That gives me this decimal. So I'm getting about 171 point, and I'm going to go to 4 decimal places. So 8873 is where I'm going to stop. Okay, and that's in degrees. The problem is they wanted it in degrees, minutes, and seconds. They do not want a decimal. So I'm going to have to convert this into degrees, minutes, and seconds. So this first part is easy. 171 is my degrees. But I need to separate off this right here. So this is plus my 0.8873. But I'm going to get this in my minutes and my seconds. So I'm going to multiply this by 60 minutes because there's 60 minutes in a degree, right? So this is going to take a minute for me to get through all of this. So bear with me. All right, so that's going to give me 0.88 times 0.8873 times 60. That gives me 60.88. No. I'm sorry, I messed up. I added 0.8873. I'm like, what did I do? Times 60. Sorry about that. That gives me 53.238, right? And that's my minutes. Okay, but again, I still have this decimal here, right? So I'm going to kind of switch this up again. So this is 171 degrees plus actually, no, let me go ahead and put my minutes. So I'm going to put my minutes over there with it, my 53 minutes. And then I've got this piece that I need to change to seconds. So 0.238 minutes. So plus my 0.238 minutes. I need to take that times 60 seconds because I want seconds, not minutes. Okay, so that's going to give me 171 degrees, 53 minutes, and then 0.238 times my 60 is going to give me about 14.28 seconds. Now, lucky for us is we can just stop there. Once we have down to our seconds, I'm going to go to right here and I'm going to forget about this 0.28. So it's 0.28 of a second. I'm not going to worry too much about that. So I'm going to round 171 degrees, 53 minutes, 14 seconds. So I can just keep multiplying by my 60 because there's 60 minutes in a degree, 60 seconds in a minute. I can just keep doing that with those decimals to convert those into what I need them. Okay, so there's a crash course on minutes and seconds. I hope that kind of makes sense. Okay, then this last one, express this, my 19 degrees, 47 minutes, 23 seconds as a decimal, and they want me to round it to the nearest 10,000th of a degree. So now I'm going into decimal form instead of my minutes and seconds. This to me is a lot easier than that last one where I had to go from decimal form into minutes and seconds. This is less complicated because I remember that I have this kind of little cheat sheet right here, right? So I'm going to look at each of these pieces, this piece right here and this piece right here, as a degree. So I know my 19 degrees is pretty normal. So I know that I have 19 degrees plus I have 47 minutes. Well, 47 minutes, because minutes, there are 60 minutes in a degree. That really means I have 47 60ths of a degree. And then this last part, 23 seconds, that really means I have 23 out of 3,600 of a degree, if that makes any sense here. So 3,600ths of a degree. So then I'm just going to get those as decimals and add them together. So I've got a 19, that's a degree, by the way, not a 0, plus 47 divided by 60 is about, so I'm going to round this, 0.7833. Again, I'm sticking with 4 decimal places, okay? Plus 23 divided by 3600 is about 0.0064 of a degree. And then if I add those together, plus 0.0064, I end up with 19.7897 degrees.